And so if the forward reaction predominates, meaning that the H2O molecules have
so I
a
did.
weaker attraction for the hydrogen than the A, meaning the A is going to be by itself, right? Because the hydrogen went here, then it's going to be a strong acid. So the forward reaction, oh, this, don't look at that. The forward reaction predominates it, like over here. Okay.
You know that the acids are losing a hydrogen. So both water and the acid want the hydrogen atom. The arrow is telling you which one's weaker.
Which one is?
Which one's more.
Oh, okay.
Contractile, right?
Yeah.
Contractile.
It attracts it.
The hydrogen
more
ion.
strong. The attraction is stronger.
The hydrogen ion.
I guess so. I was a little confused on that. Basically, it just says, I think this just means it could happen either way. Oh. And then you figure out what Okay? Okay, so then we talked about, basically, if it's a strong acid, it's going to have a weak conjugate base. If it's a strong base, it's going to have a weak conjugate acid. Remember that? I don't really understand this whole diprotic acid thing.
I think it's just an acid
Oh, it
produces
can lose
protons.
2 protons.
Okay.
Yeah. So like, sulfuric acid, H2SO4. It can lose 1 hydrogen atom to water.
And it'll still be hydrogen sulfur.
Yeah, but then it can also lose another,
Okay.
right? Is that what it means by diproton?
Yeah, I think so. That's what it means.
Okay, so it just keeps talking about
Oxyacids.
oxyacids are the ones that,
Saturated oxygen.
yes, and organic are the ones that are like HF or
Are we on
The ones that are
493 or
carbon.
494?
495.
495.
So organic acids, yeah, those are the ones attached to hydrogen.
Oh wait, nope, you're right. I misspoke. The organic acids are the ones that attach to carbon.
Organic always means
Yes.
it has a carbon.
Yeah, and then those are normally weak, and then the other important ones that are normally strong are the hydraulic, which is just like H, and then the other thing, there's no O.
What's the oxyacids is the other one?
Oxyacids is hydrogen is attached to the oxygen. Okay. So next is anomeric, which is basically saying that water can be a base and an acid, right? It's the most, it can behave as either an acid or a base, and water is the most common.
It is a very mid pH level.
I don't know. Maybe this. So basically, then it just kind of explains that, and then it talks about the product. I don't really understand why that works, but we're just gonna roll with it.
Yeah,
And
this
the,
one makes sense.
yeah,
You just need to know that number.
Yeah.
It's always going to come to that number. No
yeah.
matter what.
So H times OH always equals 1.0 times 10 to the negative 14. That's the iron product constant, and it's always equal that. So if hydrogen's bigger, OH has to be smaller. If OH is bigger, hydrogen has to be smaller.
And there's
I
a
think
unit.
that's like the,
And it's the mole point.
Is it? This is a unit
that's the
that's emitted.
Oh, I guess it is, but it's normally, it's like the concentration. It's the concentration, so it's whatever.
yeah, it's the mole area. That's what I was thinking, because
And
it
then
doesn't make
basically,
sense otherwise.
if in a neutral solution, H equals OH, and in an acidic, H is greater, and then in a basic, OH is greater. Yep.
Something I have to remember.
Yep.
And that's just because,
So that's just like the truth.
Yeah, I don't really understand why some of this works.
But then you just have to, they have to equal the same number.
right.
And I think once we get a basic understanding, we can go through and really think about it more, but I say we just get through it right now. So the pH is what we read about yesterday.
You need to know the equation.
Yes. So basically, P is -1 and N is the log. Is that what it says?
Well,
to know.
The
P
P
is
scale of
negative.
whatever n
Uh-huh.
is just
Negative log.
Yeah,
Okay.
of that number.
Okay, so you just basically, I was trying to figure this out on my calculator, but I think you just do second log, right? And then it's 10, and then you put in whatever it is.
Right?
And we can do the homework if we want
And
to.
N stands for the variable.
Yeah.
number that-
N stands for whatever it is. I think once we finish going over logs, we should maybe just finish reading. Because, or I guess we could read at home. It's just the reading's like 2 more pages, like basically. Oh, it's literally like 2 more pages.
Yeah.
So that's what pH is, and then I think,
Oh yeah, like rounding it. To say the number of decimal places for log. So so that your final answer has to equal the number of significant figures in the original number.
the decimal places in the final answer has to equal the significant figure. Yeah, so significant figure in decimal places. And so pH equals the negative log of H. And that's gonna give you, the pH scale represents acidity.
How we doing with the math part?
I think
Our reviewing.
Now, I do want to tell you that if you look up some books that say what is the definition of pH and what is the definition of pH.
It provides a convenient way to represent the solution acidity.
So it is a scale that tells us to what degree you are an acid or a base, something like that. But the mathematics says it's a negative log, and that's what the P part means. P in math means negative log of, and some books say this, hydrogen ion concentration. And what do the brackets mean? Concentration in molarity.
Okay.
So when you see brackets, it means concentration in molarity. Some books say pH equals a negative log of the hydronium ion concentration. Now, nobody likes hearing that there are 2 definitions, but guess what? If you had a million of these in water, guess what all million of them will do?
What you're saying is
They would jump onto here and form a million hydronium. So it's the same thing.
like
So if you know the concentration of these,
so
you know the concentration of
I
that.
was getting
So it's not really 2 different definitions. Some people just like to say hydronium, some people like to say
and I was
hydrogen
getting
ion.
the -7.
So that was confusing to me. I remember a long time ago. I said, which one is it?
But doesn't that mean that
This problem
can't have an acid
and I think
in water?
what it's saying is because
That's true, but the definition of an acid is a solution that, see, it has to be a solution. That's why all acids and bases have to be electrolytes. Because they are solutions that contain at least some ions, don't they? That's why they have to be some kind of electrolyte.
there's slightly more.
All right, one more thing. I think you're down to here. How quickly can you do this? Let's say number 31A. Calculate this and then indicate whether it's acidic or basic. So, first of all, what you could do is, what if you found the negative log of that? What would that give you? What's the POH?
So whichever one has more hydrogen.
That's the negative log of which ion? See that?
So we gotta find the.
Now, so here, if the hydroxide ion concentration is this, then the negative log of that number would be the POH. So what did you get for that?
The negative log of 5.99. I got 1.
Let's try it again. Let's everybody try it. It's 5.6 times 10 to the minus 8.
Yeah, I got it.
And then take the negative log of that.
5.6 times 10 to
5.99. 5.99 times 10 to the minus 8.
That's the first one I got. I said 114.
What are the calculator, maybe you're typing it, do you do
Yeah.
second log?
I just did negative.
What do you have? Is your log just plain old log? Yeah, it's not a second
that's
function.
Okay, negative log of,
7.22? All right, now, what it asks for is, it asks for the hydrogen ion concentration. Now, I just did this because, just to see if we can do it, all right? So what is pH plus POH? Okay, so let's say, what is it, 14 minus F?
Oh, no, I didn't.
Right? Now, I already know that if you're below 7, you're gonna be acidic, And if you're above 7, you're gonna be basic. So that's another way of doing it. But is there another way of doing this problem? I like the fact there's more than one way.
I did it by dividing,
Oh, I like that.
I divided 1.0 times 10 to the negative 14 by 5.99.
Okay, so the ion product constant, this times that has to equal that, doesn't it? So if they're gonna give me that, this divided by that equals this, and you would have been done. So you would already know the hydrogen ion concentration. So this divided by that gives you that. So since they asked for that, that's the way I would do it.
So,
Now, as far as whether it's acidic or basic, there's 2 ways you can do there. What'd you get for your answer anyway?
I got 1.6 times 10 to the negative 7.
And that's molarity, that's molar, isn't it?
Yes.
Now, let me show you how to do this. You might say, well, now I gotta take the pH to figure out whether it's an acid or base. So I'll show you a faster way of doing it, all right? If it's neutral, the hydrogen ion and hydroxide are equal at 10 to the minus 7.
Concentration?
Ready? Is that higher or lower than 10 to the minus 7?
It's, well, it's higher than 1.
A little bit bigger, isn't it? You're a little bit bigger in the hydrogen ion concentration. So who wins? Acid.
A would be acidic?
Acidic.
So the 10 to the, you said the 10 to the negative 7 is equal? and
Yeah,
then-
in pure water, both of them are 10 to the minus 7. 1 times 10 to the minus 7. So think about this. I can do this problem real quickly. The OH is actually lower than 10 to the minus 7, isn't it? So if the OH is lower than it should be at neutral, then that means H must be higher than it should be. So a shortcut is, you're lower than neutral. The OH is lower than H is higher, you're acidic. Or we can take the negative, can somebody take the negative along with that?
The pH is defined as equals negative log of hydrogen. To obtain the pH value of a solution, we must compute the negative log
To the minus 7.
Yeah, 1.6 times 10 to the minus 7.
6.7.
Okay, and so that's the other way. If you like math, you can do the pH and say, yeah, you're below 7, you're an acid. Or the faster way is to 10 to the minus 7 is neutral for both of them. Now, yes, you can't get tricked here. Look at this right here. Look at this. This OH is 1.43 times 10 to the minus 12.
11.
Is he higher or lower than he would be at neutral? Is that bigger or smaller than 10 to the minus 7?
That's bigger.
That's really small, isn't it? So the OH is really low, then the H must be really high, and so it's gonna be acidic, isn't it?
the hydrogen.
The hydrogen ion would be high, wouldn't it? That'd be an acid. But you can do the math, because I know you guys like math.
Okay.
Do the math anyway, and then see what happens.
So that's the pH.
So it's acidic or not, so this one was acidic.
The concentration multiplied by
Oh
the
wait,
other
we're
is
giving
1
pH,
times 10 to the negative
I think
14.
she's asking for
Basic,
hydroxide.
PO, the P scale
And,
is 14.
How we doing?
Oh, no, we're right, that's the pH.
I know you guys are gonna like the
this
math
one
part.
would be
Like that.
basic.
Kind of like, oh, I could do this.
You get 1 point.
So, B for that one would be
You said acidic?
oh, I forgot to look at this.
What are you guys?
Oh, wait.
Are you guys looking at problems?
Okay, now.
Yeah, really fast. Acidic or something, and this is helping
So
kind
if
of.
it's-
This is 36.
Oh, 33
How do we find hydrogen ion?
Oh, so it would be acidic, it's OH now, yes.
Yes.
You're right.
Yes, see that?
If it's,
All right, that's one way of doing
and then
it.
this one
That would give you a hydrogen ion concentration.
A is
And what do you have to do with that?
acidic again.
Take a
B
negative
is
log.
acidic.
Yes. Now, is there another way to do this
C
problem?
is
What if
acidic.
they take a negative log of
D
that?
is neutral.
Which one?
Yeah,
What does that give you?
okay.
For 33.
If
Okay,
I take the negative log
so
of
let's
OH,
just
it
keep
gives me
going.
what? Yeah, on
This
43A,
one is
you take the negative log of that,
That's
P
acidic.
means
Wait,
negative
that's-
log.
Okay,
That's
so now,
yeah, that's greater. So
we're gonna read,
Okay, now,
so
are we on 16.5 now?
so that's this is the base.
Wait, is it, if it's larger, is it
I think
base
we'll,
or
I
an
think it'll
acid?
help when we
If
do
it's
problems.
greater,
Yeah, but this.
that means it OH has a higher concentration. But
No. This is 8.
isn't that right?
oh,
Why does
So
it
guess
get
what?
important?
If I take the negative log of that, That gives me the.
Wait, if H is higher than
pH.
normal, is it a base?
No, no,
or-
it's smaller.
I like the way you did also.
I'm trying to figure out.
Sorry.
Wait, it is bigger, it is bigger.
Concentrate.
Yeah, it is.
Is this, okay, okay.
Then you still have to take the negative log of that.
I wasn't
Yeah,
sure
either
whether I
way, two
interpreted
steps.
like
Yeah, it is
it being
bigger.
higher.
I just want you to know,
It is bigger than
if you do it
What are
either
we-
way, it's gonna work. You try it both ways, you see it works, or say.
Well, now we got a new
Okay, yeah. He kind of did, but basically,
Oh, wait, okay, so.
Like, the pH changes by 1 for every power of 10 changes in H plus.
Wait, what page?
We're on 500.
500, okay.
Now, some books say.
We just did the calculating here.
Okay, and so we're going to
That was
page.
an inverse.
Concentration.
So,
They're lying. No, they're not lying. Right, if you had a
Find
million of those,
hydrogen
they all come on
concentration
water, you got a million of those, so whether
Take
the
the inverse
that is the
log.
same. So it doesn't matter where
How do
you
you
look
get
in
the
the
inverse?
pH, they give
Wait, where are you?
ion concentration or hydronium.
502?
how do you do the
You can do
inverse?
it either way.
That's what I was doing. It's second.
Hydronium on one of these problems.
That's what I was
Even
doing.
hydronium.
Okay. Second
Don't
one.
let that bother you.
So why would you need to ever
Why
use
would we
that?
do, to
I know,
find
that's what
C
Google said.
that's
I don't know.
the
That's not the.
Maybe we should ask him, but that's what
POH?
Google
Have to,
said.
you do it one way,
I don't think that's an inverse.
We already got the pH.
Well, it depends on which
I don't
problem
either.
you
Say that
have,
again?
because,
So when would you use the inverse law?
That's
To find,
If it was neutral
Uh,
water,
yeah,
if it was
find pH.
pH of 7,
so
neutral,
it's basically the other way around.
if you're being given
OH
this
and
OH.
H would be 10 to the
Wait,
minus
wait,
7.
wait, it's defined, so we're finding the
Is
concentration.
that higher or lower than 10 to the minus 7?
We're finding the
Higher,
concentration.
isn't it? The OH is higher
But
than
it's also
neutral
possible to
water.
find the H
So
or
if
the OH
OH
from
is
the
higher than it
pH
should
or the
be, the
POH.
pH of the H must be
So
lower than it should
to
be.
arrive at the H
Acid or
on the
base?
right hand, we must undo
OH
the
is
log
higher
of
than it was.
This is the inverse.
Oh, so if you're given the pH level, you can find the H level, the H
By doing
concentration.
the inverse.
So, Mr. Kenny,
Got it.
Mr. Kenny, so we were talking about.
So
the
wait, you need to do
log.
inverse and negative log, right? So you would.
How do you get the inverse log on the calculator?
Okay, and that's what I wanted you to figure out. There are some people that do it one way in math, and I do it another way, so I gotta figure out how, I gotta remember how you guys do it. Do you have inverse on your thing? Here, let's try one. Let's try one. What if I told you, I happen to know that the pH of 7, the pH of 7 would mean that the hydrogen ion concentration would be 1 times 10 to the minus 7. So, let's put this in our calculator and see how we can get 10 to the minus 7 out of it, right? So let's try, put 7 in there and put inverse log, or some of you try inverse log 7.
Inverse log is ln, right?
So you either put inverse log 7, but I think what you have to do is you, I hate that, I'm gonna make up a word here. I think you have to negify pH. I just made up a word here. So what I want you to do is put negative 7 and do the inverse log of that and see what you get.
Inverse, is inverse log
That's what I'm thinking
ln,
about your
or-
calculator. You have second function log.
Second log.
That'd be times the pH.
So if you
Yeah,
will
so wait, is
negify
it-
the pH and then take the inverse log of it,
Is it
are you getting
inverse
1 E minus 7 or?
Sorry, is inverse log second?
Okay, so here's what you have to remember. I just made it up. You have to negify the pH and then do the inverse log of that.
And when to do the inverse?
Okay, so what'll happen is, let's say I told you the pH was 3.2. That's the pH. And I'll say, but what I want to know is, what's the hydrogen ion concentration? So how do we do that? So you go put negative 3.2 in the calculator, and then do second function log.
But then, so you can
Now, tell me if you get a number, tell me what you get there, and I'll,
You do the same
You
thing
get
there, as you did 14
Got
months.
it.
Negative 4. Yes.
depends on what?
Negative 4.
Okay, and you know how I know that's probably right? Because if it was 10 to the minus 7, it would be pH of 7, it'd be neutral. So this guy's much higher than 10 to the minus 7, so it must be an acid, a pretty good acid. Hey! So anyway, this is that sounds pretty good to me.
Thank you.
Alright.
So, if we're giving a pH,
So when do you do the
Not
negative?
very good.
pH?
You get somebody else to do analysis.
The negative log is if you're
to
giving.
find the concentration.
We can get Jonah.
Do you want to be on an anatomy project? Yeah.
What to do.
Okay, you just have to like, here, I'll find
I think.
Did that work then to -5 pH and then second function law?
So this is if you want to find the
Now, here's where they get a little tricky. They might say this, they might say, what is the hydroxide ion concentration? And these little brackets mean molarity. The brackets mean a molarity, okay? Now, how would you do that? You just, if I said the pH is 3.2, you gave me the hydrogen ion concentration. By the way, that's in molarity. And what if I asked for the OH concentration? You've already done this before, probably.
divide
14 divided by this. Okay, that's one way of doing it. Let me show you another way of doing it. What is pH plus pOH equal?
14.
I know what's now. So what's 14 minus that? pH plus pOH is 14, right?
11.8.
11.8? Now, guess what? If the pOH is 11.8, let's do the negative pH second function of that. So see, if pOH is 11.8, then
That's 10.8.
put negative 11.8 in the calculator and say second function log, and then see, write down what you get and do it the other way and write it down what you get and say, whoa, there's another way of doing it. Let's try it again. If I give you the hydrogen ion concentration, remember OH plus OH times H, these concentrations need to add up to what number?
1 times 10 to the 4th, negative 4.
That's right, okay? So now, if you know the hydrogen ion concentration, then this number divided by that will give you what? One more time. Sorry. What we did here, we went from pH all the way backwards to the hydrogen ion concentration. See that? And then, what if I said, what is the OH concentration? Well, this times this always equals that. So this divided by that, give you that. And so that's one way to find the OH concentration.
Why is the concentration of 2 lower than concentration?
Of what now?
Why is the concentration of 2 lower than
This
the
is 14,
concentration
so you
of 1?
subtract.
What does that mean, 2 and 1? Point this.
So, the concentration of this is this,
Yes.
which is higher than 1.
One, that's true. But guess, if you'll calculate that for
Very,
me,
very low.
find out what that number is. They're both very low, yes.
Okay, so 1 times 10 to the
Negative 14, and then divided by, now you have to use parentheses, whenever you put a scientific number in the denominator, you have to use parentheses, right?
Is that true if you use E?
That's a good question. I don't know about that. I would say yes, but I don't know, because E means times 10 to the. Whenever I divide by a scientific number, you should put in scientific notation. Okay, what'd you get?
1.5,
8,
9, 8
Times 10 to the-
times 10 to the negative 11.
And that's the OH concentration, right? So I wouldn't mind if you tried it both ways and said, hey, I'll find the pOH first, then take the reverse that, inverse log of that, and you should get the same number. All right.
Thank you.
We haven't really learned that much beyond this. First quarter over here.
Takes into the power of the pH.
Okay, I think we should make a game plan.
Okay, so wait, so you did your.
So you're doing it backwards, because in like 41 you took the negative.
Just do it.
I don't think the exam will be that hard.
Okay, so I say we make a game plan. I don't know what time it is. So we have today.
Way easier math.
So today, we have today and Monday. So I say, should we read them today? Or should we do questions right now and read over the weekend?
Opposite of that.
You've already read. It's
We
only
have
2 pages.
6.5,
So-
right? We only have 6.5.
Oh yeah, it's only 2 pages.
So maybe we should just read right now. Let's read. Okay.
Yeah, that's not much.
Let's read and then
Have you guys been reading this school?
I started it. Like when we first started it. I was like,
Yeah, that's what I did, but I don't.
I don't think we
give
need
it-
to read that.
Okay, I say we just read it, get through it, and then we can dissect it, just so that we get it done.
Are we starting?
Yes,
That makes sense.
so, calculating the pH of strong
then where did
acid
you get the
solutions.
9.6?
In this section, we will learn to calculate the pH for a solution containing a strong acid of a known concentration. For example, if we know a solution contains 1 molar of whatever that is, of HCl, how can we find the pH of the solution? To answer this question, we must know that when HCl dissolves in water, each molecule dissociates or ionizes into H and Cl ions. That is, we must know that HCl is a strong acid. Thus, although the label on the bottle says 1 molar HCl, the solution contains virtually no HCl molecules. Okay. A 1 molar HCl solution contains positive H ions and negative Cl ions rather than HCl molecules. Typically, container labels indicate the substances used to make up the solution, but do not necessarily describe the solution components after dissolution. Okay, everyone good? In this case, that's what it looks like. Therefore, the H in the solution is 1 molar. The pH then is the negative log of that. Okay, everybody good? That makes
Subtract
sense?
that number from 14.
Yeah.
Yeah.
The concentration.
Honestly, I can do that at my house.
So
Let's just skip these and go on
the
to 14.
pH is 0, meaning that it's super, super, super acidic. Because you know the thing is,
Oh, yeah.
yeah.
I was thinking of. Yeah, I was thinking of the
You
concentration.
could,
Yeah.
but you're looking for,
Okay, so,
in
there,
reality,
I'm
you're
gonna
looking for
just
the
write
pH.
very low acidic, because what is the thing, it's 1
So
to
if-
14?
in order to just
Is that
find the
it, or
pH,
0 to
sounds
14?
right.
It's 0 to
Subtract
14.
0 to
that number
14.
Although
up
there
to
are
very
acids
low.
that are
Very low.
below 0.
Subtract 7, you get
Okay.
S 7. And then
So,
as you get 1
buffered
to
solution, a
10,
buffered solution is one that resists a change in its pH even when a strong acid or base is added to it. For example, when 0.01 moles of HCl is added to 1 liter of pure water, the pH changes from its initial value of 7 to 2. Okay, because you added a very strong acid to the water, a change of 5 pH. However, when 0.01 moles of HCl is added to a solution containing both 0.1 molar acetic acid and 0.1 molar sodium acetate, the pH changes from an initial value of 4.74 to 4.66, a change of only 0.08. Okay, I don't know why that happened. Let's keep reading. The latter solution is buffered. It undergoes only a very slight change in pH when a strong acid or base is added to it.
Because it's.
I know, I
Because these are
know.
acids already. Right now.
So
So-
the solution contains both of those acids.
Yeah, they're
Yeah.
confusing
Which
acids.
are weak, I think. Those like
Well,
weak acids.
I think what happens is a certain amount of, because a reaction takes place that would reduce the pH level, but an additional reaction takes place at the same time that raises. And so it kind of, it mostly cancels out.
Oh, it says buffered solutions are vitally important to living organisms whose cells can survive only in a very narrow pH range. Many goldfish have died because their owners did not realize the importance of buffering the aquarium water at an appropriate pH.
The buffering changes it.
Buffering is when that doesn't change
Yeah,
very much.
it causes it to.
No, so the second example talks about it.
Yeah,
The second,
What about the first one?
the first one
that's
is
not
Okay.
buffering. Yeah.
So, for humans to survive, the pH of blood must be maintained between 7.35 and 7.4. This narrow range is maintained by several different buffering systems. A solution is buffered by the, okay, here it is. A solution is buffered by the presence of a weak acid and its conjugate base. Okay, that's important. An example of a buffered solution is an aqueous solution that contains acetic acid and sodium acetate. Okay, so this is the acid and then that's the conjugate base. Acid conjugate base. Okay, so sodium acetate is a salt that furnishes acetate ions, the conjugate base of acetic acid when it dissolves. To see how this system acts as a buffer, we must recognize that the species present in this solution are. Okay, so when it produces a separate ions. Okay, so.
So why wouldn't acetic acid? Oh, because it's a weak acid, yeah.
Because it's a. Oh.
Yeah, that's why it's not dissolved.
Okay. What happens in the solution when a strong acid such as HCl is added in pure water, the H ions from the HCl would accumulate, thus lowering the pH.
Would the H
The
ions-
H ions would accumulate, that means like maybe separate, thus lowering the pH, therefore making it more acidic. Right? The H separates, so it becomes more acidic. Okay. However, this buffered solution contains C2H3 ions, okay, which are basic. That has a strong affinity for H, as evidenced by the effect that acetic acid is a weak acid. This means that acetic acid ions, or C2H3O2 ions, and H ions
and just go like this? Like move your shoulders
do
down.
not exist together
For the anatomy
in large
class.
numbers.
So,
We're videoing like
so there
staff and
exists
students
like
doing
one out of every 100
Because,
ion.
because if they stay
It's
together.
the fresh
Yeah, but it's a
blood.
weak, it
Logan's
doesn't
doing
mean
the
it
opposite,
doesn't
so he's moving his shoulders
associate at
up.
all.
Right, just
And
a,
it
Yeah.
like one time, but
just a
there
very
is.
small number.
Yeah.
Okay,
Three,
so because
two,
this ion
1.
has a.
Did I do it right?
For
Yeah, you got it.
These two combined
I don't know. Let me see it. I know if I can
Look like you're joking.
H3O2. Thus, the H from the added HCl does not accumulate in solution, but reacts with C2H3O2 as follows. I don't really understand that, but I guess we can keep reading.
I think what it's kind of getting at, basically, when the hydrochloric acid is added, the H ions go to the weak acid
Oh.
instead of just accumulating in the water, and it forms a non-acid.
Maybe keep reading and think about it. So next, consider what happens when a strong base, such as sodium hydroxide, is added to the buffered solution. In this base, if this base were added to produce water, the OH ions from the solid would accumulate and greatly change the pH. Raises it by making
So,
it.
when you have strong acid added to water, it lowers the pH. On the other hand, if you have a strong base, it also raises. No, it raises the pH.
It is, because it says they're all strong.
Okay. So it says like right here, HCl, which is a strong acid, lowers the pH, and then a strong base.
Raises it because
Raises
it's
it.
lower, it's more acidic. So, okay, so.
Wait, so why does
We're going over buffers right now. We're doing buffers.
HC2
Oh, you're on buffers?
We haven't done the questions.
Are you
yet.
okay with the math?
I think so. I think doing the questions, we haven't done them yet, but hopefully doing the questions
Okay,
will like nail it
if you
in.
know you're done with the math, I can start helping with buffers. But if you, I can help you, just to make sure that you, I think I got the math part down.
Yeah.
And then I'll come back.
Okay.
pH changes for like
Okay, so where are we with the?
However.
However, the buffered solution, the OHR, has a very strong affinity for H reacts with the HC2H3O2 molecules as follows. This happens because although C2H3O2 has a strong affinity for H, OH has a much stronger affinity for H and thus can remove H ions from acetic acid molecules.
It's okay.
Note that the buffering materials dissolved in the solution prevent added H or OH from building up in the solution. Any added H is trapped in that to form HC2, H3O2. Any added OH reacts with the H2, H3O2 to form H2 and C2, H3O2. The general properties of a buffered solution are summarized here. Okay, yeah, I'm gonna need some help with that, but.
So then,
So,
a buffer solution is just one that's
when
not
you
balanced.
have a solution of NaOH and HC2H3O2 or acetic acid and sodium hydroxide, the
So then a buffer solution will be
OH
something
from the sodium hydroxide takes the
Oh, but then
hydrogen from the acetic acid
Yeah,
and
that makes sense.
water.
Yeah, the acid is donor.
Yes, and
Well, the
so
base, which is
that turns
sodium.
acetic acid into a base,
Yeah, and then
and
the conjugate.
and the Na
Living cells can survive
and the
only.
Na
Okay, that makes sense. More efficient diet because of the owners and the importance of
and both are kind of
with an appropriate pH. So
water.
describe pH that one was limited.
I'm a little lost on that, so hopefully you'll explain. Okay, now, how do we want to do these last couple questions? We want one person to do them, or we all want to do them and
What are we
for
starting at?
answers? I think I have done up to, my next one is 37. Also, I had a couple different answers that I wanted, the ones that you sent me.
Yes, I understand, yeah, we.
What happens in this solution?
But I don't know if I'm right, like, I think he should give us the answers and then we can check. We'll only check one of ours.
Yeah, that's fine. I don't know.
So wait, what questions do you want to look at?
So we have 1624. And also, do you know if we do the addition from?
The 37?
Are we looking at 37? Why do scientists tend to express this?
Oh,
It's pH that is in terms of the molarity of the hydrogen ion present. How is
we do the additional.
Because
You said to do it like
has a
97,
strong
right?
attraction to the hydrogen molecule, so it's a weak acid.
It was the odds to 9.
So instead of a hydrogen just and it's ion state just bouncing around in the water, just chilling, right? It goes,
But
a
at
lot
the
of the
same
hydrogen
time,
ions go with that acetate.
Okay.
And
So,
we should
we
probably
want,
High affinity for H.
let's do up until the additional problems for right now. How's that?
for 37,
Doesn't accumulate in solutions
it
because
says,
of the reaction.
why do scientists tend to express the acidity of a solution in terms of its pH rather than in terms of its molarity and hydrogen ion?
Hydrochloric acid in this situation.
Let's go with that.
So the HCl is gonna dissociate in the water, but then.
Because it's so small, it's the base of the scale, right?
That's, yeah, I think that's partially it.
So what does it say? Why do
Let's
scientists
consider we're averaging a strong base
express,
of
to express
sodium
small
hydroxide
numbers
solution.
conveniently? Yeah.
Yeah.
Okay,
And pure water, the
so,
OH ions from
I
the
can
solid will
say
accumulate and greatly change pH.
scientists do
Which
this
is very strong affinity for H plus.
because in order
So,
to express
What are some other weak bases or acids that would be good buffers?
extremely
You
small
know,
numbers
besides acetate, I feel like
conveniently.
I feel like they use acetate a lot.
Yeah. Hydrosulfuric acid, right?
It looks like carbonate.
How is the pH defined mathematically? It is,
Okay, I get buffering.
Okay, yeah, it looks like carbonate.
How do we do that later?
Yeah, we'll talk about that later.
okay, so pH,
Okay, so for the question,
Would
59,
be,
what's your?
I think this is equation.
it is the negative law.
Yeah, I think it's what's that?
When you put a strong acid in
pH
solution with
equals
weak acid,
negative log
is that
of H.
specifically what
Are you
they-
doing
the
brackets?
pH value is lower than
Yeah. Yeah,
If at all, right?
Yeah, it does.
You guys got.
Will differ slightly
negative
when an
one.
acid is added or acid base is added.
Yeah, I'm just gonna also say,
is it negative 1 log n or negative log h?
The N is like generic, like we could.
Yeah, that is variable.
So it could be, okay.
So H is log, negative log H. And that's 39.
39.
For a hydrogen ion concentration of 2.3
Oh, yeah, yeah.
times 10 to the negative 6 molarity. How many decimal places should we give when expressing the pH of the solution? 3.
Okay.
What? I'm just like saying.
There are 3 significant
Yeah,
figures.
just saying, like, because.
But that's the original number.
Like your rules.
Yeah, you.
Yes, okay.
If I be like number 6,
Where do you want? Calculate the pH corresponding to the hydrogen ion concentration given below. Okay,
So you
so
want to just do it separately and
And
then
then
see
check
if-
our answers,
Yeah,
yeah.
see if we do it wrong already.
I just wanna make sure that you're gonna take the negative log, right?
You guys are in
Yeah.
buffers, right?
14.
Yeah.
Have you gotten to 61?
Oh, no, we haven't done the question.
Like math so well, you're just gonna take the negative log and say, hey, you're less than 7, you're an acid. But
Reverse
really,
log of
if you were neutral,
12.9
H and OH are 10 to the minus 7.
is
Now you're telling me H is what?
5.
Your H is higher than you would have been as neutral.
Do you guys want to like talk about it after each problem or just do it over the phone?
Acid or base?
Okay. I got 1.2.
Eight.
Yes.
So is that just saying calculate, so pH?
And that's what you said, it's higher.
1.283 though, right?
Yes. Oh, right, wait,
Wait, but no, because it's negative to
1.28 would be the decimal. Oh, no, you're right, you're right. You're right.
Should we read a question about
because
61?
it's much higher. Because for a second I was like, wait, 2 is not
It's
greater.
we just don't really know what it is.
Okay, and
Okay,
then,
and I don't have it memorized.
so it's past acidic, correct?
So,
It is acidic, yeah.
How do we know it's acidic?
Because, so think about the little scale, so it's 0 to 14.
yeah, because negative 2 is greater than negative 7.
Right, so what do you do?
It's acidic.
Just how we
Yes.
just.
We just couldn't find exercise 60. That's asking
Oh.
about.
That's the main question.
I think we understand what it's asking for. We just don't.
Just like 60.
Don't really get it.
I just read the equation now.
No, I think they meant, it must be
Just
that.
to the log.
What component is capable combined with it?
So I got 11.155.
It's not really, what is the? We have to come up with an
And
example.
then that is,
Okay, but what we're gonna do,
That's sure.
what we're gonna do is we need to tell a story, okay? So, anybody, can we go to the story? Let's go to the story first. Then,
Okay, I'm gonna go back to buffer one really fast.
you know, I heard that word so much in college, but I had no idea what they meant. And so, unfortunately, I never heard it in high school, never. And,
6.4 and
all right, so
9.
now, did you tell me what a buffered solution?
and then now.
Buffered.
Yeah.
But why make it, how about that? Why make a buffered solution?
If you want, well, for example, if you want like a pool,
So
what
it's-
pH is
I think
like
it's
acidic,
acidic.
you want a buffer solution.
Yes.
The C is
We have a pool. We just put a pool. If there's a pH, if you don't want the pH in the pool to change, so that.
I think the key to
you want a buffer
to
solution.
buffers is that it's strictly measure of hydrogen ions.
If I'm a scientist working with enzymes, you know this, you cannot allow that pH to change very much or else you'll lose your enzyme. So you'd have to have a buffered
So
solution in
anything,
there.
So then I guess would be like filling, I guess.
so anything below 7 is a base.
So,
But like 6.99,
making a solution
I guess.
that if somebody accidentally.
Well, because it's based on
strong
1
acid in
times
there,
10 to the
it
7.
would
Where'd you get the
rarely
negative?
rarely
Where'd you
change
get
the
the
pH, but normally it would
I guess
change it
these
by
are
a
all the
lot.
same.
What if
What
somebody
number
poured
did we
base
just
in
do,
there, like
41?
strong base?
Yeah.
pH wouldn't change it very much. So something like that.
Is for OH to do the negative log of that?
Calculate the pH.
Pretty much, like 2
So yeah,
Oh, no, wait.
we find the
means,
find
you
the
know, like,
pH,
do,
pH,
right over here, right over here.
Subtract it from 14.
Maybe, maybe somewhere else,
Let's do
maybe
it.
it won't be
Let's do
fine,
43.
right?
That's
The
really
buffer
the
means,
concentration
give me a little
pH, like
time to, let's not have something happen quickly here, let's, anyway, you can use it as English terms too.
This,
Ah,
this,
here we
you're
go.
looking for pH, so you are just working forward,
That's
so
what
you're
you're
trying to work
starting to do. That's what you're starting to do.
Like this is one of the numbers that you
Buffer
are solving
solution
for
is one that resists changes in pH.
But you don't need it.
Or for one acid or bases are added to it. Did I get that? See,
So I got the OH,
There it is.
That's
Now,
like,
or wait,
what I need
they'll give you
is,
and they're like,
B is dumb.
I got 9.87.
it's so
subtract,
For one? For A?
Yeah. 9.87.
and then you subtract that from 14.
Oh, I
But-
think it's a, yeah,
okay,
yeah,
so
yeah,
I'm
yeah,
confused on why, is that right?
So,
Is that what
says
you
I
do?
need a week.
So we're trying to figure out pH, right? And doing the negative log of pH, so we found the POH and then you subtract that from 14 to get the pH. Yes. Yes.
Yeah, just find the pH.
So
Yeah. For a second, I just stopped at the POH.
So this is POH and then 14 is minus 0.13 because POH and pH equals 14 equals 9.87. So that's the pH, so it is basic.
Okay. For the next one, it is, the number they have there is 1.51 times 10 to the negative third.
What is it?
So it's pH, the A, acidic or basic?
I said
Basic.
basic because the pH is the 9 value that we found.
Yeah.
So it's close to 14. It's past 7, it's greater than 7. So it's basic.
If I put acetic acid.
Does that make sense?
Because on the scale, it's a 7.
Higher
And
than
then higher than 7 is basic.
that's hard to, because if you think of higher than 7, that makes me think of 8. But it, on the scale, it's higher than 7. Really, it's less than 7. So like 6, 5, 4, that's acid. And then 8, 9, 2 is basic.
Actually, it's not acid, so it's.
Okay.
What you're getting is you get the
So
hydrogen
whose
ions,
do we want to turn it?
hydronium,
of these?
Here's your blood.
and then what's your leftover?
Okay, I think I probably have some wrong. Yeah, that's totally fine. I probably have some wrong, so when you mix the solutions, we'll check mine. Okay.
Alright, and then for B, have you guys done B yet?
I got 11.1.
And then we would do 3 decimal places?
Where does the NA plus come
Oh, I
three
guess you
decimal
do
places.
have to concentrate on
Make a
that.
buffer, I need some acetic acid.
And then that would be basic as well.
I'm gonna mess that up a few times on the test.
You guys done B yet?
Wait, so when do you leave the 3 decimal? At the
You,
POH?
it's sig figs.
Yeah, so you could do 1.51 times the negative.
What if?
There are 3 sig figs in the original, there needs to be 3 sig figs in the pH.
Sodium acetate in water. Into what? And would you get the acetate ions you want?
So it's basic.
And then the sodiums would be.
Yeah.
Not doing anything. What if I use potassium acetate? Can I do
I got
that?
12.52.
You give me some ionic acetate, and I know it dissolves in water.
Okay, so
That's where I get my acetate. But then have to be sodium.
3.31.
Well, it could be, this is iron acetate. If I look on that chart, and if it's. Yeah. I could actually take almost any
Not yet.
acetate,
Doing it right now.
put it in water, and guess what I would get?
Yeah.
I know it sounds confusing, but you're not gonna be doing anything.
I got,
Let's tell a story. I have some of this, and I have some acid.
I don't think that's what I'm gonna get.
The last one?
Oh, for the last one?
Yeah, that's the last one.
What did y'all get for C?
Oh,
I got
12.5.
And that's basic.
pH to change.
So it would be 12.5 and 2, 0.
No, you have 3
Drop that pH, wouldn't it?
because the original
Oh,
is
man, I do want that to
only
happen.
3 sig figs.
Yeah,
You have
3 decimal
3
places.
sig figs.
So you should have 3 decimal places.
Yeah.
No,
Oh, so
no,
then-
no, no, you should have 3 sig figs in total.
3 decimal. it's
Decimal.
decimal places.
Decimal
It's
places.
sig figs for,
Yeah, it starts off with the original number of how many sig figs are total, how many sig figs you have, and that's how many decimal places you're gonna have.
so how
The other
many,
numbers.
You're doing
how many
multiplication
sig figs
and
are,
division, you're not doing.
It doesn't matter whatever, that's just the rule, I think. Like, no matter what, I think that's the rule.
Alright, so.
so 11.18, so it should be 11.180,
Alright, you know what you're talking about.
right?
I'm saying I'm not sure.
We can always check.
Is it how many sig figs you have in the beginning is how many decimal places you have?
I
God.
think,
So,
that's what it says right
so
here.
for D, I got like 5.955.
God.
That's
Yeah, 5.95.
No, 5.
That's it.
So we have Monday to work on.
Yes.
Yeah, because we already finished reading it, so we could go over,
Oh.
I think we're almost done.
That'll be
So,
good.
go over buffers. Yeah, lots of numbers. But I don't want to take the
5 is
concept.
really easy.
Okay, so should we end this?
Wait, what did y'all get
So-
for D?
Oh yeah,
I got
5.955.
Yes.
So we're gonna go over buffers on Monday. Answer the questions that we know, except excluding buffers, for Monday also.
Okay.
So we should, so I should, how many questions this week?
No, do the questions except for the buffers.
Okay.
And then we'll do buffers.
Or do you think we almost have time on Monday to do them in class, like together?
Well, I'm just confused if you, I don't think we'll have time to go through all of them.
I mean, if it's
Well,
just
if you know how to
all-
do them, it might be a review of the whole thing, right? Is that okay?
Should
Yeah, it
I?
might be a review of the whole thing.
Okay, so over the weekend, I just could probably do 16.4 questions.
And then maybe there's additional questions. If we know how to do them, I'm not sure. I'm guessing it's something to
Do it Monday, right?
That's true.
Yeah, and then you can just, yeah, I guess. We'll have the ending for that.
Wait, so do we just do additional type of questions? Is that a sign?
I think 10 does. 10. Yeah. I don't want to take this test.
Me neither. So what are y'all doing this weekend?
Dude.
16.4.
16.
Do the question.
Do the question.
Love you, John.